Okay, so, okay, turn around. Get out your notebook. Right, thank you. Make sure you take notes so that you know how to do these things. Those notes are really valuable. So we're going to talk about systems of equations. This is the beginning of a whole new chapter, okay? A whole new chapter in math. Oh my God.
Don't let me distract you while your movie stuff.
Are you gonna be around for a bit? Or
No, I'm done.
You're done?
Way done.
Okay, well we'll talk.
I'll see you next time.
I'll see you next Thursday. Okay, great. It's good to see you, buddy. So systems of equations. I just want to help you understand why they're important, right? And so I actually used a learning target today because I'm supposed to learn how to use these. I never use them. It's not me, but I'm going to try. And sometimes I see that they're valuable because I want you to be able to understand why systems are important. They're really, really, really valuable in life. In fact, many of the word problems that I've already taught you, some of the word problems, are way easier using systems than they are the way I taught you. Okay, so Rowan, you got to be turning around, facing forward, and you have to have your notes out. Okay, I just want to make sure. And so they're really, really valuable. A ton of stuff can be done with systems of equations. You're going to see as we move forward. When we get to word problems, you're going to realize, oh my gosh, there's so many possibilities. Number two, that I want to be sure that you can solve them by graphing and understand what solving is, okay? So that's what we're going to look at today. But first of all, up until this point, most of the stuff I've given you have had one variable. Don't you agree with me?
Yes.
Like I would give you an equation, and I would give you like, 2x plus 4 minus x plus, well, not plus, equals, 8x minus 1. And I asked you to solve for x, right? You have one unknown, am I right? Just an x. And you have one equation, am I right? So you can solve for x. When you have one unknown, you can solve for x with one equation. Always, right? Immediately, 2x minus x is x. X plus 4 is equal to 8x minus 1. I'm going to subtract an x. That gives me 4 is equal to 7x minus 1. I'm going to add my 1. I've got 5 is equal to 7x. Divide by 7. X is equal to 5/7. That's it. It's exactly 5/7. It's not 5/8, not 5/9, it's 5/7, period, right? We can solve when we have one equation and one variable. You can always solve for that variable. Always. Right? Powerful, right? Now the problem is, then we moved and we started graphing, and we talked about two variable equations, right? When I gave you two variable equations, like y is equal to 2x plus 1, and I asked you, is it legal, would it be okay for me to say solve for x and y?
Yeah.
Yes, I could say that, but there wouldn't be any way to do that. I can't, x, we don't know. I mean, like, I could use a t-chart, right? I could use a t-chart. If x were 0, 2 times 0 is 0, so y is equal to 1. Y would be 1. Maybe that's it. Maybe x is 0, maybe it's 1. But wait a minute. What if x were 1? What would y be? 2 times 1 is 2, plus 1 would be 3. You with me? So suddenly, there's no way to solve for x and y here. Do you follow me? I have two unknowns and only one equation. It's impossible for me to solve for x and y. Impossible. So what do? I would just graph it, and I would graph all my possibilities, right? And I've got positive 1 and up to, somebody's humming, by the way, over 1, up to, yeah, there we go. And I graph it. And this line goes on forever and ever. This represents all the possibilities of x and y. Are you with me? Does it make sense? But I don't know which one is the answer. I don't know which one is the x and y they wanted me to solve for. because I have two unknowns and one equation. All right, so here's the key. If you have two unknowns, you need to have two equations to solve, to actually know for sure x is this and y is this. If you had three unknowns, an x and a y and a z, how many equations would you think you would need? Three. You would need to have three equations to absolutely, definitively decide that x and what x is, what y is, and what z is. So systems of equations is really cool in that it allows us to work with more than one unknown, right? In life, there's usually more than one unknown, right? There usually is. There's usually more than two unknowns. There's often like tons of unknowns. So you're going to need tons of equations to technically solve them, right? To find out what they are. We're going to only focus on two equations at a time. And we're going to solve them, meaning in the first instance, we're going to try graphing them and we're going to see where they cross, right? And so you guys know that part, okay? Every time I look at Gavin, he smiles. I'm thinking, did I say something funny? No, I don't think I did. Okay, all right. But okay, so the first thing that I want you to practice is understanding how to know if a point is a solution to a system. Okay?
What?
All right, so watch this. Let's say I gave you this. I said, determine if the given point is a solution to the system. So here we go. If I gave you this problem, let's see. Let me grab one. Y equals 2x plus 2, and y equals 4x plus 6. All right. And the point that I'm actually going to give you is This board is weird. -2, comma, -2. All right? So I'm asking, is this point the solution, the absolute exact value for x and the exact value for y that solves this system? So the way I know is I remember every point is an x comma y. So my first number is my x. My second number is my y, right? And so I'm going to plug those in to each equation. So I'm first going to start with the first one. Y equals 2x plus 2. And y is -2, so I put -2 equals 2 times x is -2, I put -2 plus 2. Right? So I have -2 is equal to -4 plus 2. Well, -4 plus 2 is -2. -2 is equal to -2. I get a truth. It doesn't say something that's false, that's true, right? Therefore, that is a solution to this, meaning that point is on this line. That's what a solution means. It's on that line. Does that make sense? That point is on that line because when I plugged it in, I got a true answer. Okay, did you get that? So now I got to try it with the other equation, right? So we got y is equal to 4x plus 6. And it says that -2 is y, is equal to 4 times -2 is x, plus 6. So -2 is equal to -8 plus 6. -8 plus 6, that's -2. Oh, -2 equals -2. So yes, it's true again. This is totally true. Therefore, it checks. It checks for this equation, and it checks for this equation. Therefore, that point, this point, is where the two equations cross. It is the solution of the system. And I have now determined that x, when I say solve the system, I figured out that x is -2 and y is -2. I've proven it. Does that make sense? You get it? So you're going to get some of these. You're going to get 4 of these on your homework tonight. Just like this. And all you're going to do is you're going to plug in your x and you're going to plug in your y. Let's do one more just to be sure you guys are... I hope that's okay to erase that. I didn't ask, sorry. But I don't have quite as much space today. All right, so let's try one more. Let's try... let's try this. 6x plus y. So this is going to be written in standard form is equal to 37. And then I'll say 4x plus 2y is equal to 12. And the point is 7, negative 5. So I'm being asked again, is that point a solution to the system? So I'm going to write my first equation. 6x plus y is equal to 37. So the 7 is my x, and the negative 5 is my y. So 6 times 7 minus 5, right? Is that a 5? Minus 5 is equal to 37. All right, well 6 times 7 is 42, right? 42 minus 5 is equal to 37. 42 minus 5, so 2 away from that, and then 3 more, 37. 37 equals 37. Awesome! So we know that point is definitely on this line. That's what we know. It's definitely on that line. It's one of an infinite number of points on this line. Now we got to see if this is also one of the points that is on this line. So, I mean on this line, sorry. So now we've got that. That checked. We got 4x plus 2y is equal to 12. And I'm going to say, okay, x is 7. So 4 times 7 plus 2 times negative 5 is equal to 12. 4 times 7 is 28. Minus 10 is equal to 12. 28 minus 10 is 18 is equal to 12.
Not true. Not true.
So, can I just see that? No, that.
This? This?
So 18 is equal to 12, right? 18 equals 12. So you should be writing this down, right? 18 equals 12. So, so is that true?
No.
That's not true. That means that is not a solution to this equation. It is a solution to this one, but it's not a solution to this one. But in order to be a solution to the system means it has to be both, right? It has to be true for both. So it's not true for the second one. Therefore, no. Absolutely not. No, not a solution. Not a solution. Right? Or you could just say no, right? But do you see, does it make sense? Fist of 5, do you guys understand that? Pretty straightforward. Now, ironically, this is exactly what we're going to do when we graph an equation. After we have finished graphing and we find a point that we think is the solution, we're going to just quickly check it with the initial problem and see if that point is correct, is the right point. Does that make sense? Okay, so now we're going to go to that step. We're going to graph. We're going to solve a system, and we're going to see how they where they intersect. So we got y equals. Here's our first one. Y equals negative x plus 4. And our second one is y equals 2x minus 8. And I'm being asked to find the solution. Now I'm not giving you the point. We've got to find that point, right? Does that make sense? Just to make sure that I can see stuff, right? So what am I going to do? The first thing I'm going to do is I'm going to graph it. So here's my graph. And I have to graph very carefully. And I am going to use a ruler if I have one. Because the ruler is really important. Otherwise, I'm likely to mess up. And I've got to be really careful. And it's really hard because I'm making a very fast inaccurate graph right now. But you guys have the fortune of having graph on your homework, graph paper on your homework. So you know it's going to be accurate, right? As long as you're careful. Okay, so these are both in slope-intercept. So my slope is -1/1, and my y-intercept is 4. So I go up 4, 1, 2, 3, 4, and I put a dot. And it's -1, 1. So I go down 1/1, dot. But I'm going to keep going. Down 1/1, dot. I'm going to keep going. Down 1/1, dot. I'm going to keep going. Down 1/1, dot. Keep going. Down 1/1, dot. Keep going, right? I just kind of keep going so I can see where all the possibilities might be. If I needed to, I would keep going that way, but I don't. I'm going to wait and see. Maybe the other line comes up here. If so, then I would go up 1/1, up 1/1, right? To the left. And now we're going to try it. So that's this one. Whoops. You got the idea. And then this one is 2x minus 8. Let's just do that one in a different color. So 2x minus 8. So my y-intercept is -8. 1, 2, 3, 4, 5, 6, 7, 8. Ooh, okay. And then I rise 2 and run 1, right? It's 2/1. I rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Where am I? Rise 2, it's up here, and run 1. Ah, look at that. We share that point. We share that point. There was another black dot there, right? So now I got to figure out what is that point. It's on the x-axis. It's 1, 2, 3, 4, comma 0. 4, comma 0. 4 to the right, and then nothing up and down. Now I have to see if that is really true. So I'm going to quickly do this. Y is equal to x. Okay, so -4. Wait a minute, not. Oh yeah, wait. I see this. Sorry, rewrite it. Y equals -1x plus 4. All right. So my x is 4. My y is 0. 0 is equal to -1 times 4 plus 4. So -4 plus 4 is 0, right? So 0 equals 0. That checks. I'm going to try this one. What was that again? 0 is equal to 2 times 4 minus 8. That's 8 minus 8. 0 equals 0. That checks. Right? You can do it quite quickly, this part. It's just to prove that you're right. Does that make sense? That's all it is. This is the important part, but just you use your algebra to just prove that it's right. And that's all it is. So I'm going to give you the homework to work on. Does anybody have questions on how it works? Did you see the value of doing my slope many times? Because then suddenly my dots actually intersected. The dots themselves, they shared the same dot. That's why it's so valuable to do the slope as many times as you need to, right? I might have done a few and then found out that the line crossed here, so then I would go back and be sure I'd go all the way down with my slope with the other one again, right? I would just kind of keep doing that. Now it's a little harder fortunately I think all the homework tonight has y equals problems, so it's going to be slope-intercept form. So they're really easy to graph, really easy. I just plot this on my y-axis and I do rise over run, right? So this should be really easy. At some point though, you'll start to get them in standard form as well. Standard form is a little harder because you don't have the slope so much. You know, remember, you've got your x-intercept, and your y-intercept, right? And then you just draw a line between the two. So it's a little harder. So you just have to be really careful with your graph, right? With your line. Oh, and I was going to use my ruler, and I forgot to. But I didn't really have to, did I? Because my dots proved that I got it right. Does that make sense? If I don't have the dots to prove it, I've got to be really careful when I draw my line with my ruler. Does that make sense? Okay, that's it. That's it. That's the first step. And you're going to find that it's not, for most systems of equations, this is not an easy way to solve them. It's not an easy way. But it's a pictorial way, and it helps you understand what you're doing. You're trying to find that point, right? So at least you understand that part. But then as we move forward into, like tomorrow, I'm going to do a lecture on how there's two other ways to solve them. Well, there's several ways to solve them, but we're going to talk about three ways. The first one is by graphing. The second one is by substitution. And the third one is by elimination. And I'm going to put those all up on the board tomorrow so you can see those three ways. And then we're just going to focus on one of those algebraic ways tomorrow. Much easier, much faster, and much more accurate, okay? And you don't have to be so careful. You don't have to worry about your straight edge and whatever like that. Anyways, that's it. So hopefully that was clearer.